Hi friends, welcome back to Hobby Plus. Today I will discuss about the push-pull amplifier and what is the result of this bridge rectifier. That is not a bridge rectifier actually, that is a edge bridge circuit, that is a push-pull type circuit here, and that is the edge bridge circuit for drive the transformer for next step. Here you see that there is a signal generator. I always tell this IC signal generator because that is in that IC you can get pulse, that is your signal which can drive your MOSFET, transistor or IGBT, whatever it is. That's why I tell every time that is your signal generator. Look at this, that is very interesting. That is your output A and that is your output B. When output B is on, then output B is off, and vice versa. So you get a signal in lag and lead. That is your push-pull amplifier, this part and also this part. That is for one channel and that is for one channel, that is for one channel and that is for one channel, another channel. Okay, look at this, why it is called push-pull. First point. Second point is what is the benefit of this push-pull circuit. First point is why it is push-pull, because it sometime it push the ampere, sometime it pull the ampere from the output MOSFET, transistor, IGBT, whatever it is. When it is off, that means you get 0 volt here, that means it is in off condition, and also this MOSFET, this transistor in off condition, that is a 0 level. That is your first stage, I think. Suppose that is your first stage, you just on this circuit. In that moment, this MOSFET is off and this MOSFET also off. Okay? Why? I tell you. After some time, when this pulse is going high and this transistor is on, then the power, that is your power line, you know, that is your power line, that is 12 volt power, that is your power line. Power come through this MOSFET transistor, then get here, but in that moment it is high point, your transistor base is high, but emitter also high, but both are same because there is a resistance, so this voltage is lower than base, that means that transistor is off. You get a power here, you get a voltage here, you put this voltage in this two MOSFET, one is here and another is here. So this MOSFET is on, this MOSFET also, then your power come here, charge the coil, primary coil of this transformer and go back to the through this MOSFET to ground. That is your first level. That is your first level. This push-pull amplifier do this first phase. When this get pulse back to 0, then this transistor is off, but this transistor is on. I want to know why. Because when I on this transistor, power come through this path and put in the gate, that means this capacitor, that is not physically connected with the gate to source. First of all, you have to remember that. That is your internal capacitance. Each and every time I told you that is your internal capacitance, that is not external capacitor. This capacitor also charged. When this this transistor is off, power off from this path, but capacitor still in charging condition. Then you get again, then that is your source, that is your power source. In that moment when this transistor is off, that is your power source, because it is charging condition. You get a 12 volt here, and when it is off, that means that is 0. Then your base voltage is 0, but you get here 12 volt, so it is in conductive mode. So capacitor discharge through this transistor here and make both of them make to neutral. You can get a fresh transistor, you can get a fresh MOSFET in this part. After one firing, I am called that is your first firing. So that is after one firing you get again a 0 level MOSFET value. That is your 0 level MOSFET value. Okay. When and also you have to understand, I have to complete this over. Then a power comes through this path, charge the capacitor coil of the transformer, go back to this path, I already told you, and that is anti-clockwise. Suppose that is anti-clockwise. So you get here a pulse, that is, suppose that this part of this pulse you get for this pair. When it is off and this pulse come out from this signal generator, that means your this part, that means second push-pull amplifier is on, and do same thing with this pair, one of them here and here. In that moment your power comes through this path, goes to coil, back to the MOSFET, this goes to ground. That is anti-clockwise. So you get a opposite pulse here. That is your full wave pulse amplifier. You get this type of pulse output of this transformer, and also that, that is absolutely used for your next stage of the circuit. But these transistors are working like a discharge these capacitance, all of them. Some capacitor discharge to this transistor, some capacitor discharge to this transistor. That's why this is a pull circuit and that is your push circuit. You push the voltage to the gate, you pull the voltage from the gate. That's why it is push pull circuit. That is your push part, that is your pull part. Don't forget that. And why you cannot get any noise? Due to this cause. Because this transistor discharge this capacitor and this capacitor. So no charge are accumulate on this gate, both of them. Remember it. Follow, there is no slew, there is no noise, there is no different output. You get from all, you start always from 0. Always after one fire, if it is your first fire, then you get again 0 due to this. That is your pull circuit. After all, I have to tell you something. if it is your chopper transformer or driver transformer. That is not a chopper transformer, I am sorry, that is a driver transformer. You can drive this path through this path at next stage. Okay, and you have to know what is the wattage calculation of this transformer. Here is suppose 0.5 watt and also here 0.5 watt. Then you have to make, or you have to winding the transformer with a very good calculation, very calculative way. You have to go a very calculative way, that is 0.5 and that is 5.5, means your transformer wattage is 1 watt. When you winding this transformer, you have to calculate it. I want a 1 watt transformer. So your primary also 1 watt, because you know primary wattage and secondary wattage is absolutely equal. But some losses in the transformer, hysteresis loss, heat loss, so many circumstances are there. But all of them you have to calculate this. Now I think this video is helpful and I think you learned something about this video. Please do this. You know what to do. In the next morning I will meet with a new video with a new topic. Thank you for again